Paints, pesticides, cleaning products and perfumes now contribute more to urban air pollution than cars. That's according to a study that claims we have underestimated the toxic impact of products that contain compounds refined from petroleum. For one type of pollution, tiny particles that can damage people's lungs, particle-forming emissions from chemical products, are twice as high as those from the transport sector. The researchers also found that people are exposed to very high concentrations of these compounds indoors, which can be 10 times more concentrated than outside. Scroll down for video. The study, published today in the journal Science, was conducted by SCIRES, the Cooperative Institute for Research in Environmental Sciences. SCIRES is a partnership between the National Oceanic and Atmospheric Administration and the University of Colorado Boulder. As transportation gets cleaner, those other sources become more and more important, said Brian McDonald, a SCIRES scientist working in NOAA's Chemical Sciences Division. The stuff we use in our everyday lives can impact air pollution. For the new assessment, the researchers focused on volatile organic compounds, or VOCs. VOCs can waft into the atmosphere and react to produce either ozone or particulate matter, both of which are regulated in the United States and many other countries because of health impacts, including lung damage. Some people living in cities and suburbs assume that much of the pollution they breathe comes from car and truck emissions or leaky gas pumps. This was true in past decades, but regulators and car manufacturers made pollution-limiting changes to engines, fuels and pollution control systems. Following these changes, McDonald and his colleagues reassessed air pollution sources by sorting through recent chemical production statistics compiled by industry's regulatory agencies, by making detailed atmospheric chemistry measurements in Los Angeles air, and by evaluating indoor air quality measurements made by others. The researcher concluded that in the U.S., the amount of VOCs emitted by consumer and industrial products is actually 2 to 3 times greater than estimated by current air pollution inventories, which also overestimate vehicular sources. For example, the Environmental Protection Agency estimates that about 75% of VOC emissions by weight come from vehicular sources, and about 25% from chemical products. But the new study, with its detailed assessment of up-to-date statistics and data, show that the split is actually closer to 50-50. The disproportionate air quality impact of chemical product emissions is partly due to the fundamental difference between those products and fuels, said NOAA atmospheric scientist Jessica Gilman, a co-author of the study. Gasoline is stored in closed, hopefully airtight containers, and the VOCs in gasoline are burned for energy, she said. But volatile chemical products used in common solvents and personal care products are literally designed to evaporate. You wear perfume or use scented products so that you or your neighbor can enjoy the aroma. You don't do this with gasoline. The team was particularly interested in how those VOCs ended up contributing to particulate pollution. A comprehensive assessment published in the British medical journal Lancet last year put air pollution in a top 5 list of global mortality threats, with ambient particulate matter pollution as the largest air pollution risk. The new study found that as cars have begun producing cleaner emissions, the VOCs forming those pollution particles are coming increasingly from consumer products. We've reached that transition point already in Los Angeles, McDonald said. During their research, McDonald and his colleagues found that they could not reproduce the levels of particles or ozone measure in the atmosphere unless they included emissions from volatile chemical products. The researchers also found that indoor concentrations of VOCs are often higher than outdoors. Indoor concentrations are often 10 times higher indoors than outdoors, and that's consistent with a scenario in which petroleum-based products used indoors provide a significant source to outdoor air in urban environments, said Alan Goldstein, a co-author from the University of California. Berkeley. The new assessment finds that the U.S. regulatory focus on car emissions has been very effective. It's worked so well that to make further progress on air quality, regulatory efforts would need to become more diverse, said co-author Just Degau, a Sires chemist. It's not just vehicles anymore, according to the Environmental Protection Agency. There are 6 major pollutants which can impact on human health and well-being. Particulate matter. Particulate matter is the term for a mixture of solid particles and liquid droplets found in the air. These particles come in many sizes and shapes and can be made up of hundreds of different chemicals. Some are emitted directly from a source, such as construction sites, unpaved roads, fields, smokestacks, or fires. Fine particles, 2.5 parts per million, are the main cause of reduced visibility haze in parts of the United States, including many of our treasured national parks and wilderness areas. Carbon monoxide. Breathing air with a high concentration of CO reduces the amount of oxygen that can be transported in the bloodstream to critical organs like the heart and brain. At very high levels, which are possible indoors or in other enclosed environments, CO can cause dizziness, confusion, unconsciousness, and death. Nitrogen dioxide. Nitrogen dioxide primarily gets in the air from the burning of fuel. NO. It forms from emissions from cars, trucks and buses, power plants, and off-road equipment. Breathing air with a high concentration of NO can irritate airways in the human respiratory system. Such exposures over short periods can aggravate respiratory diseases, particularly asthma, leading to respiratory symptoms such as coughing, wheezing, or difficulty breathing. Sulfur dioxide. The largest source of sulfur dioxide in the atmosphere is the burning of fossil fuels by power plants and other industrial facilities. Short-term exposures to SO can harm the human respiratory system and make breathing difficult. Children, the elderly, and those who suffer from asthma are particularly sensitive to effects of SO. Ground-level ozone. The ozone layer in the lower area of the lower portion of the stratosphere, approximately 12 to 19 miles above the surface of the planet, 20 to 30 kilometers. Although ozone protects us against UV radiation, when it is found at ground level, it can cause health problems for vulnerable people who suffer from lung diseases such as asthma. It is created by chemical reactions between oxides of nitrogen, NOx, and volatile organic compounds, VOC, that are found in exhaust fumes in the presence of sunlight. Lead. Major sources of lead in the air are ore and metals processing and piston engine aircraft operating on leaded aviation fuel. Other sources are waste incinerators, utilities, and lead-acid battery manufacturers. The highest air concentrations of lead are usually found near lead smelters. Depending on the level of exposure, lead can adversely affect the nervous system, kidney function, immune system, reproductive and developmental systems, and the cardiovascular system. Infants and young children are especially sensitive to even low levels of lead, which may contribute to behavioral problems, learning deficits, and lowered IQ. Source: EPA.
Where the freaks at?